All right, welcome back to Computer Science S75. This is lecture 1 in which we actually dive into PHP. So you pull up your browser, you hit www.google.com, and you hit enter. Can we play back this story? What happens first? And try to impress everyone with as much technical detail, but just one step as possible. Give me one step in this process. You have hit enter. What happens? Yes?
Communication with the DNS server.
OK, so there's some communication with the DNS server, whereby your browser asks the local operating system what is the IP address of google.com. If your operating system itself does not know, it in turn asks the local DNS server. And who typically owns or controls these DNS servers? Yeah, your ISP. So Verizon, Comcast, Harvard, your company, anyone along those lines. And if your company or your ISP does not know what the IP is for google.com, what happens next? Yeah.
They probably know another DNS provider that knows, so they'll redirect you to that.
Excellent. They probably know some other DNS server, and so they ask a bigger fish, followed by a bigger fish, and so forth. And worst case, there are these root servers that at least know where the other authorities are for the various .coms, .nets, .orgs. And the reason that all works is that when you buy google.com or your own personal domain, you at least have to tell your registrar what. Yeah?
The DNS server of where you're getting your website hosted.
The DNS servers of the hosting company or whatnot where your website lives. And that's typically called NS1 and NS2, just conventions. But the important detail is that there's usually two DNS servers that in turn know your website's IP address, knows your domain name's email servers, and the like. OK, so now my browser knows the IP address of google.com. What happens next? Yeah?
It sends a GET request.
Good.
Get the root of the actual hard drive.
Good. So we told the story of the virtual envelope, aka packet, and that's sent from point A, you, to point B, Google. And inside that envelope is this message, get me, / and then there's some reminder of the protocol that's being spoken, HTTP/1.1 or whatnot. What's also inside of that packet? What amount of information?
Could be a reminder of what actual web address the user typed in.
Good. So a reminder of the address the user typed in, which is the host HTTP header. And this is crucial for what feature offered by today's web servers? Someone else, yeah. Virtual hosting, whereby you can put many websites on the same physical machine and even on the same IP address, because browsers, thankfully, will remind the server what host name was actually requested so that the web server can distinguish between your website or someone else's website and so forth. All right, so this virtual envelope goes to Google. Google opens the envelope, so to speak, sees get / realizes, oh, you want the root of our website. In Google's case, that's all of the HTML and other assets that compose their homepage for searching. And so they respond with a packet of their own or more packets of their own, inside of which is all that HTML. Your browser receives it, renders it, connection is closed. Now, in terms of more subtle details, browsers these days are fairly smart in that rather than ever have to ask the operating system, Mac OS, Windows, whatever, what the IP address is of google.com, a browser will cache that IP address typically. So this just means it's slightly more efficient than asking the operating system and certainly more efficient than asking local DNS servers. But there's a gotcha. And one of the themes of this course will be to try to point out some of these details, because if you are not just a user, but you're actually a web developer trying to build new websites, suppose that the IP address has been cached, but suppose that you move the website to another server or another virtual machine. There are these gotchas you might run into, and so one of the recurring themes of any sort of web development, especially in this PHP world, is constantly be clearing your cache. And one of the upsides of using Chrome, frankly, for primary development is it has incognito mode, which while usually is used so you can browse sketchy places online, can also be used to a developer's advantage in that it will prevent cookies from being saved and other details from being cached. But even then, it's not perfect. And even I often have to quit the browser entirely, clear my cache manually. If you ever notice anomalies happening or like, I know I changed that file, it could just be some stupid cache issue. So put that in the back of your mind so that you don't waste 10, 20 minutes some night this summer chasing down a bug that you actually already fixed. Caching takes many forms, and DNS is just one of them. All right, so any questions on that big picture of HTTP? Yeah, all right. So where does this all fit in? So this is the picture we essentially just painted verbally. So what's on the end of point B? In this case, Google or some other server. So one of the most popular web servers out there is Apache. This is freely available software. It can run on Linux computers, Macs, Windows computers, but it's super common in the Linux and Unix world in particular, and those tend to be machines used for web servers these days. It is the A in LAMP. So LAMP is just a silly buzzword, Linux, Apache, MySQL, PHP, and that's just a buzzword saying I'm using all of these various technologies. But common jargon in the industry is to say that I'm running a LAMP stack. And that just means you have Linux as your operating system, Apache as your web server, and so forth. And so there's nothing technical about the term, but we'll be looking at the individual pieces. So one of the latest versions of Apache is 2.2 point something. This is the documentation there. I will say from personal experience, I've never found it the most user-friendly. So frankly, Google is a better friend, to me at least, than Apache's own website, stackoverflow.com, serverfault.com. These are wonderful places where smart technical people post generally useful solutions to common problems. So keep an eye out for make use of those resources as you see fit. But what are the kinds of things that you can do with the web server configuration? Well, virtual hosting. So this is a representative snippet from a file called httpd.conf. And let me just pull up a little scratch pad so we can type out some notes here. The blackboards are occluded by the projector here, so we'll use TextEdit. So this just so happens to be the name, typically, of a configuration file. However, you might also see it as apache.conf, apache2.conf. It really depends on your operating system or the distribution of Linux, for instance, that you're using. But the important takeaway is that this is typically the main configuration file for an Apache-based web server. And Microsoft's IIS server has similar features. There's other web server software, but Apache's definitely among the most common. And here's a representative snippet from that file that apparently is implementing what feature for the web server, if you can infer. Kind of just guess by reading it. Yeah.
Well, first off, it's a port 80, so it's a regular website.
OK, good. So you see a port 80 at the very top there, which suggests it's indeed a sort of standard website living on a standard port. What else comes to mind? What other feature is being conveyed by this config? Yeah. Database. Where are you inferring database from?
Is that 443?
44. Oh, so not 443 is actually used for SSL. So there's two pieces here. We can, and we'll focus on both. But first, the top one, port 80, is sort of the simpler of the two. So let's look there first. So I'll pluck this one off. So virtual hosting. This feature whereby a web server can use multiple, the same IP address for multiple websites is implemented literally by way of a file like this. This is telling the web server, and the top thing there is just a comment. This is telling the web server, hey, define a virtual host, a vhost, on port 80 of any IP address that the server has. So star denotes anything, and in this case, it's meant to mean an IP address. And this is relevant because if the web server just so happens to have multiple IP addresses, this is a wildcard character that just says, doesn't matter what IP address the request comes in on, go ahead and just listen on port 80 on all of those IPs. So another common thing, especially if you're developing on your local virtual machine, which is increasingly common and is, again, what we'll do in the class. Sometimes you do need to know the IP address, especially in various cloud environments. So just be mindful of sometimes star is not sufficient unless you have a configuration, another layer of configuration that I'll wave my hand out for now because we're just looking at a snippet here. So this says listen on port 80 on any IP address that this server has for incoming requests. Now, when requests do come into the server, thankfully, they should have that host : HTTP header that reminds the server what this request was for. So if you skim through some of this, and let's skip the top part now, server name, this is where the vhost's name is actually defined. And we'll see it down here, too. For the SSL version, the name of this website will be the same. But I've also defined what we'll call an alias, which is just what in this case? Quick sanity check. Yeah?
The same site, just .www.
Exactly. The alias here is just CS75.net with no www. So this is just one of the steps necessary to ensure that both www.cs75.net work and cs75.net work. So the quick story I told on Monday about certain websites just not working with just something.com or the like is because someone did not think to configure a fairly minor detail like this. Again, this is Apache, but other web servers, Lighty, Nginx, and others have similar features. So this is one step. And just to tie Monday to tonight, what was the other key detail that you need to do to ensure that both work, both www and no www? Not a redirect. Redirect is really just to ensure the user ends up at the place you want. But you want both destinations fundamentally to work. So we needed a DNS record, an A record in particular. So we needed to specify that CS75.net itself has an A record, and we need to specify that www.cs75.net has an A record, or what other type of record could we? Multiple aliases, which we called CNAMEs on Monday. So CNAME or canonical name. Now this too is sort of a corner case technically. Unfortunately, you cannot generally make CNAMEs for the root of a domain. CS75.net cannot be a CNAME for something else, but something with a host name, www, FTP, mail, .something.com, those can all be CNAMEs. And that's a bit of an oversimplification. You can have CS75.net be a CNAME technically, but things like email tend to break as a result. So let me just make the blanket statement that this has to be an A record, this can be an A record, or a CNAME. So just little things you need to keep in mind when setting up, for instance, your own domain name that you've just bought. Server admin, so this is just a fluffy detail so that if there's ever an error on your website and you see like 404 or something like that, if you haven't customized the error message, the footer of the web page is generally going to give the email address of webmaster@something.com. In this case, we're telling them to use this address just because. So it's not something like webmaster, which doesn't exist in our case since we're such a small shop. Lastly, custom log, error log, these kind of do what they say. It's just specifying the folder in which you want logs to be stored. And the most important line here, though, perhaps, is document root. Now, this is kind of crazy long and cryptic. It just is what we as a class decided to do in terms of the layout of our hard drive. However, all this is telling the virtual host is that the HTML files or PHP files, GIFs or pings for this virtual host called www.cs75.net live specifically in this directory on the server. Very often this will be a much shorter path for normal people, but we've kind of laid ourselves out fairly hierarchically, which is why it's so long. But that's all it means. All right, any questions? And again, this is something that for the first project you'll have an opportunity to tinker with and even break if you want, and you'll be able to restore it rather easily. All right, so the virtual host on port 443 is a little more interesting, but also mostly a duplicate, but the few lines are new. Which ones jump out at you is obviously new. So all the SSL stuff at the bottom. So SSL is kind of a pain to set up, at least with certain web servers, whereby you have to configure a few files. So what is SSL? SSL is Secure Sockets Layer. This is the protocol that websites use to communicate securely with browsers. But what is necessary before you can actually use SSL on your website? Does anyone know? What's involved in doing this? Yeah?
I think you need to distribute a certificate that the user will have to get.
Exactly. You need to distribute a certificate that the user will need part of, will need to get somehow from you. Thankfully, it's all automatic. So how do you go about getting an SSL certificate? So there's a couple of things you can do. You can either create one and sign it, so to speak, yourself, or you can pay someone else. And have you ever been to a website that said, whereby the browser, upon visiting it, yells at you as saying something like, this website cannot be trusted, only, you should not go here, for some reason like that? So that's because that website probably doesn't have a certificate that was signed by what's called a certificate authority. And I think it can actually simulate this. I just happened across this the other day because I wanted to make one of my university websites run over SSL. So let me open up Chrome here and type in https cs.harvard.edu. Enter. Perfect. Perfect example. So CS department has not paid for what's called an SSL certificate, ironically. And I would fix this, but it's a great demonstration. So what does this mean? It means that the site isn't necessarily insecure per se. It pretty much boils down, and this is somewhat pessimistic, to the fact that we have not paid for an SSL certificate. We have created an SSL certificate whereby that's just a command. On a Linux computer, you typically run a command called openSSL with some fairly arcane command line arguments and hit enter, and that gives you what's called a public key and a private key. What does that mean? Well, for our purposes here, just know that there's a fancy mathematical relationship between this thing called a public key and a private key. They're really just big random numbers. And mathematically, people on the internet can use CS75's public key to encrypt information to us. So if some random user is trying to visit Harvard's CS website, their browser automatically will say to cs.harvard.edu, can I please have your public key? And the browser will send it for free and over the internet publicly. It's not something that's secure. Public key is meant to be, by definition, public. That browser will, behind the scenes, unbeknownst to the user, use that public key, that big random number, to encrypt their request. And the request could be something stupid like get/. And that's literally all my request just now was. But it encrypts it nonetheless. And you can probably guess, what is the only number in the world that can decrypt something that's been encrypted with the public key? The private key. And that's something my server or the CS department server keeps to itself. And you don't give it out, and the web server is never going to send it. It's stored somewhere on the hard drive. Now, mathematically, that key will be used with a mathematical formula to reverse the effects, essentially, of the encryption, so that what the CS department's web server finally sees is get/, or whatever it is the user wants. And conversely, it works in the other direction. When you install a browser, your browser generates a public and private key pair so that the traffic can work in the opposite direction as well, if necessary. So what's the takeaway here? We did all of that in the CS department, but we didn't pay someone else to certify that we are Harvard University's CS department. So the way SSL works on a higher level is that there's this chain of trust that humans in the world have tried to build up, whereby there's big companies like VeriSign is one of them, GoDaddy's another, and maybe even Namecheap does this, even more cheaply than others, whereby you have these fairly big entities in the world who charge you money to then stamp, so to speak, your certificate as valid. What does that mean? They digitally sign it. So there's actually some interesting mathematics there that are involved, but at the end of the day, it's in part a marketing thing whereby the whole world of internet users, are trusting that if VeriSign says this SSL certificate belongs to cs.harvard.edu, if I trust VeriSign, I should trust this website. Now, how does VeriSign do the authorization? Well, some of these registrars or these sellers of SSL certificates, they'll go to reasonable lengths to make sure. They'll call you on the phone. They'll check some business records. That's what you get if they're really being diligent. But the reality is all they do is send an email typically to whoever is on file as the owner of the domain name. And in this case, it's Drew Faust or someone like that for harvard.edu. And that person has to say, yes, I own this domain and I approve the digital signing of this certificate. And then you get back your digitally signed certificate. And what you do as the system administrator is you install that digitally signed certificate, which frankly is a big number supplemented by another big number. And you install it on in your web server using the syntax that we just saw, and we'll see again in just a moment. So how do you get this certificate? Well, you can go to someone like VeriSign, and let's do that, verisign.com. And here we have, let's see, lots of products. So, here we go, buy SSL certificates. And okay, you know it's going to be expensive when they don't tell you the price right away on the page. So let's compare all SSL certificates. Okay, so what do we get? Let's see, let's just spoil the surprise. Okay, here we go. Okay, they're still not, oh, there we go. Okay, so here's what an SSL certificate apparently costs if you go through VeriSign. And mind you, it's just for 1 year. So you're essentially renting their approval for a year. What you get now is what here? Different encryption strengths. So if you're familiar with cryptography, the more bits in the cipher, in the encryption algorithm, the more secure, in theory, the transmission is. Extended validation, not quite sure what this means, probably has to do with something like the duration of it. The warranty I've never really understood. You're going to pay $400 and somehow they're warrantying your website for $1.5 million. I assume the fine print says something like, if the cryptography we use is broken, fundamentally we will pay out this amount. I'm just making that up. But the reality is this is pretty meaningless, all of this. And the fact that you get the right to put Norton secured sealed on your website is atrocious, because anyone can put an image tag on a website that says something like that. So a lot of this, realize, is trying to create an industry around sending a message of security to end users. But seeing this should never mean anything to anyone. It just means that someone knows how to embed an image on a website. And the takeaway here, too, is that using VeriSign isn't necessarily all that compelling. If we instead go to GoDaddy.com, which again tries to sell you everything in the kitchen sink when you visit their website, at least is more reasonable when it comes to SSL certificates, whereby you can get away with $69.99 a year, or the premium SSL. And in this case, premium SSL, which is a feature a lot of these SSL providers have tried to market in recent years, does really one fundamental difference. What does it mean when you visit a website and the address bar, it not only says HTTPS, but it also turns green and says the company's name in that address bar? What does it mean? Yeah?
It's supposed to mean this site is really secure and you should really trust it.
Right. But in reality, what does it effectively mean based on this?
They paid $100 as opposed to $70.
Exactly. They paid $100 instead of $70 to get that right. Now, before we just said these sentences, how many of you knew that a green address bar meant something fundamentally different? Okay, so even so there's the question. Is it really worth $30 to convince no one in this room that your site is more secure? So I'm being a little pessimistic with all of this, but frankly, I do think this is a bit of a scam, that we've built up this whole industry that in theory is actually a wonderful idea. These chains of trust, whereby if you trust someone authoritative, like VeriSign or the like, you can then trust anyone they trust. But the reality is it's so easy to get an SSL certificate these days, and even until recently, most browsers did not put these crazy sounding messages in front of the user. You might see a little broken link or a broken padlock icon, but they didn't really raise the bar. One thing Google has started doing is putting up a site like this, but I dare say, and this is a made-up statistic, 9 times out of 10 when you see this message, it's just because someone hasn't paid for their SSL certificate for the year, or it has lapsed. I do this all the time. Once a year, our website starts saying this because I forgot to pay the bill for the SSL certificate. But fundamentally, it's a wonderful idea, because it means that you might be visiting a site that is not who they claim to be, because rather you're the victim of what might be called a man-in-the-middle attack, whereby someone has gotten in the middle of your DNS traffic, and even though you think you're visiting cs.harvard.edu, some bad guy sitting in Starbucks has actually led you to his website instead and is trying to trick you into typing in your username and password or the like. So again, the mathematics, the technology itself is wonderful, but the fact that there's this market of paying hundreds of dollars versus tens of dollars is a bit unfortunate that that's where we're at. Yeah?
This message will only appear if port 443 is active and SSL is being offered.
Enabled, exactly.
Otherwise, it will not appear.
Correct. If the web server itself is not configured to listen, so to speak, on port 443, then you will just get a dead end, and you'll get a generic browser message saying server not found, or something to that effect. So you must, per the configuration we started glancing at least have your website configured to listen on both of those TCP ports. Recall our discussion of ports on Monday. We can do a little introspection here. If I click the X up here and then zoom in, server certificate does not match the URL. Server certificate has expired. Server certificate is not trusted. So we're really not doing so well here. So let's click on certificate information just to see what, oh, but the irony is, but we have a very secure connection to whoever the hell this is on the internet. So let's click certificate information, and we'll get a little more detail. So it looks like this certificate expired in May. So I'm guilty of the same. So I can't really poke fun of them for doing this. But if we click details and scroll down, we see that the certificate they're actually using for cs.harvard.edu should actually be eecs.harvard.edu. That's electrical engineering and computer science. So unfortunately, I've just revealed who's responsible for the certificate, but he's no longer here, so it's okay. But what the takeaway here is that there's a few solutions. Either one, you pay the bill, and then at least one of those messages goes away. And it's not just a matter of paying the bill. You have to download an updated certificate to install on your web server with an updated date for expiration. But more than that, we also have to fix the domain name. And so you have a few options here. You either, one, buy a separate SSL certificate for cs.harvard.edu in addition to eecs.harvard.edu, or you can buy what's called a wildcard certificate. And for instance, the course, CS75, we have this ourselves. It's unfortunately like $199 a year, but what that means for your money is that you can protect and avoid these kinds of warnings for star.cs75.net, any subdomains you want. And we happen to use things like mail and others for back-end technical reasons. So for us, that actually tends to make sense. So there's a few solutions here. And I should say, too, one of the other reasonably compelling reasons to pay more money to a bigger fish than someone like GoDaddy or Namecheap for SSL certificates is that as part of this chain of trust, the various browser manufacturers, Microsoft, Google, Apple, and so forth, they ship their browsers, Safari, IE, and so forth, with certain certificate authorities' own certificates installed. So in other words, it's up to those big companies of browsers to decide which certificate authorities should you trust. And some of those vendors, Microsoft, they might have a list of certificate authorities you should trust this long. Google's might be this long. Really depends on the company. So if you go to some fly-by-night operation, or you yourself digitally sign your own certificate, which is mathematically possible, if you are not trusted, or that fly-by-night SSL company is not trusted by Microsoft or Google, you're going to get this kind of warning. So one of the things you're paying, and if you frankly are a Fortune 500 company and the difference between $300 or $1,000 isn't such a big deal, to make sure that more of your customers reach your website correctly, it might be worth spending more money. Because it could be that someone's got the latest version of Android and for whatever reason it didn't ship with the right certificates, or someone's using version 1.0 of Netscape or something like that, and so certificates aren't trusted inside of that. So again, you're paying to minimize the risk of users running into this kind of unrecognized message. But that's orthogonal to the expiration, which is just a matter of we let the bill lapse. Any questions? No? All right. So how do you actually configure this? Well, when you create your certificate running a command on a computer, you end up with two files. One is a key, and one is a certificate. The key one is a private key, one is a public key. This line here, SSL certificate key file, this is literally where our private key can be found on the server. For security reasons, I've faked it as path to cs75.key, but it's somewhere on the hard drive. And I should make clear, it is not in the same location as your HTML files and GIFs, because that would be stupid if anyone could just download it. So it's somewhere else. The certificate key, SSL certificate file, this is what you're paying for. You upload your public key to GoDaddy or VeriSign. They then send you back via email or a download a digitally signed copy, which has your big number and essentially their big number. And then you install that here. And then lastly, this chain file just has to do with some SSL providers, whereby just in case one of the certificate authority certificates didn't ship with a browser, this chain certificate essentially says, we trust this person, so it's OK if your certificate's assigned by them. So I've glossed over some of the technical details, and it turns out, as maybe nice a theory as this is, SSL itself is still completely broken. Like, it can be circumvented. And I'll actually try to dig up an article, and I'll post it on the lectures page after tonight, if you're curious to see an interesting presentation on the various ways in which you can thwart SSL and trick users into thinking it's secure when it really isn't. So nice story, but the whole world is broken anyway. Any questions about SSL? There's one corner case that you need to be mindful of when setting up your own website. Running SSL on your website requires that you have a unique fill in the blank. Requires that your website have a unique IP. And this is one of the genuine gotchas with SSL. You have a sort of catch-22 with SSL. Because SSL is about encrypting information, what gets encrypted? Really everything in the request and the response. So everything inside of the virtual envelope is encrypted. What are some of the things inside the virtual envelope? Well, the get line, and also
the specific server you would be on a virtual.
Exactly. The host header, which tells the server which vhost this is for. But the problem is, as we're looking at the configuration here, every vhost can obviously have its own SSL certificate, because it might be foo.com, bar.com. These could be very unrelated entities if this is a snippet of a shared web host's web server configuration. So if you're getting encrypted requests, but the only way to figure out who the request is for is to decrypt the request. But to decrypt the request, you have to know who it is for, because the SSL certificate key, the private key you should use, is tied to that vhost, you again have this catch-22. You can only figure out who it's for by knowing who it's for. And so there's in theory workarounds. You could try all possible private keys you have on the system, decrypting it, but that's not necessarily deterministic, and it's also a little hackish, especially if you have hundreds of vhosts on a server. So the de facto result is that you just can't do it. But if you give every vhost a unique IP address and then associate effectively the certificate with that IP address, then you're safe. Because then you can just assume that if it comes in on IP address w.x.y.z, it must be using this SSL certificate. And there is one corner case. If you have a wildcard certificate, like we, the course, do, thankfully with a wildcard, we don't need a unique IP address for all of our subdomains, FTP, mail, web, and so forth, because if they all come to the same server, you can use the same wildcard certificate to decrypt all of that traffic. So in short, when you sign up for a web host, if you want SSL, which frankly these days it's just a good thing to have, good practice to get into, it's probably worth paying a few dollars more to get a unique IP address, because otherwise your users will get that very scary red message. And Chrome makes it easy to click through. Firefox, you literally have to click like 5 buttons in order to get past the warnings. It's atrocious. No normal user will ever figure it out. So paying for an SSL certificate is sort of a necessary evil these days. The end result is great, cryptography, but a bunch of hoops you have to jump through. All right, so any questions? Yeah?
When are you going to post the paper that you mentioned? Which website you're going to?
By morning. I'll dig up the URL, and then I will post it on the lectures page of the website, so that if of interest, you can check that out. And let me just pull up our slides here and go to... So what about this? This is among the more cryptic pieces of syntax that's useful to know, or at least get comfortable with, or get comfortable copying and pasting. Because with Apache, you can actually start to do fairly powerful things, and this is perhaps one of the most common. This is using a feature of Apache, and other web servers have very similar functionality, though they might call it something different, called URL rewriting. So mod rewrite just means module rewrite. This is an optional feature you can enable in the Apache web server that lets you rewrite URLs. Now, even if you've never seen this syntax before, what do you think these 3 lines of monospaced text are doing? Yeah?
Compensating for omissions and misspellings.
Compensating for omissions and misspellings? Sort of. That's actually a good thought. The only catch there is that if a user does mistype the address, it won't necessarily work unless DNS is configured to at least deliver the user to this endpoint. So in other words, if they accidentally type www.cs75.net, that will be a dead end unless we in DNS have allowed that to work with an A record, for instance, or a wildcard record, which is also possible. What else might this be doing, though? That's on the right track, though, and this is a very concrete case that we're solving.
Maybe it has something to do with checking if it's HTTPS.
OK, good. So is it checking whether it's HTTPS? So it's technically not, though it's very close to doing that. We could tweak it in a certain way. Yeah?
Is this kind of like a redirect type thing almost?
It is a redirect. And what's it redirecting from and to, do you think?
The top one to the bottom one.
From the top one to the bottom one, sort of. So that's actually pretty close. So let's start teasing this apart. So the very first line does what it says, turns the so-called rewrite engine on. If without that, also this is a common thing I often forget about, nothing's going to work unless you explicitly turn the engine on. So first line does that. Second line is a condition. So you can think of this as sort of a cryptic way of implementing an if-else type condition. So if the HTTP host variable. So what is this? Anything with a %, curly brace, and then a capital phrase like that. It's what's called an environment variable on the web server. There's a whole bunch of variables that are set just sort of automatically for you when a user visits. Among them is HTTP host, and that is a variable that specifies what is the IP address, or literally the word, the host name or domain name that the user visited. It's equivalent to the host line, if you will, from the HTTP request. So bang here is part now of a regular expression. So if unfamiliar, a regular expression is a pattern that you're trying to match. Bang is the opposite of true. So it means if the HTTP host is not going to match the following, don't proceed any further. So what are we trying to match? The caret symbol means what in a regex? Regex is a fancy way of saying regular expression. Not anything. That would be dot. Not any case. Caret symbol. Anyone else? begins. Perfect. So caret symbol means the beginning of the variable's value must start with www. This is to avoid accidental substring matching, where you're matching part of the domain name, but not all of it. So this means you must start matching from www. In other words, the first letter in the host name must actually be www. It can't be xyz www. So www, I have a backslash dot. Based on what I just said about dot significance, what is backslash dot? It's an escape character, so it means literally a period. If you just say period, that means any character can be here. Backslash dot is only a dot can be here. CS75.net /.net means it must match literally period net. And then this, NC, is fairly arcane, just means no case. It's case insensitive. Doesn't matter if the user had the caps lock key on, this will still match if the word is correct. So if the HTTP host is not equal to literally www.cs75.net, proceed to do the following line. What does the following line say? This is a rewrite rule. So this is the, if you have an if else, this is the if then part of the expression. So if, then do this. So this thing here, let's come back to and focus on this. I am going to rewrite the user, rather redirect the user to https://www.cs75.net /$1. What does $1 maybe refer to for those familiar with regexes?
I think it's whatever the user typed in after .net.
Exactly.
So if you would have like a, yeah.
Exactly. So let's go back to this. What is this doing? Parentheses, in the context of regular expressions, generally mean capturing parentheses. So this cryptic sequence of symbols here means dot star. So dot is any character. Star means 0 or more of the preceding thing. So this means 0 or more characters, capture them. Where are you capturing them from? Exactly what you said. Anything after the slash that the user typed in is captured by these parentheses, and by convention is stored in a variable called $1. If I had a second pair of parentheses over here for whatever reason, then I would have access to $1 and $2 and 3 and 4. So it's a generic way of not knowing in advance how many parentheses you might have, but you can at least express yourself after the fact. So this just ensures that if the user visits something/abc, I will not be redirecting the user to www.cs75.net. That's it. I will also have the courtesy of sending them to /abc. And this is infuriating how few websites actually do this, especially in mobile phones. If you're in the habit of reading news or whatnot on your phone, this is a detail that drives me nuts. I'll go to like Google News, which has links to all sorts of websites. I'll click through, and for whatever stupid reason, the website will decide, oh, you came to us from Google News, but we want to show you the mobile version of our website, so let us send you to m.news.com. or whatever it is, completely forgetting what the URL was that you were at. So the end result is you can't view the article that you clicked on. Well, how do you fix this? Simple as something like this. Now, if they're not using Apache, it's going to be a little different, but the fix is fundamentally that simple, to remember what the user typed in. So again, in terms of user experience, in terms of running your own websites, super simple thing to do, and certainly to your user's advantage. Because if you're like me, you just leave that news site and never come back because it was annoying to visit in that case. All right, and how about a couple more technical details? R equals 301. Anyone want to guess what that's referring to?
Isn't that the redirect code?
Yeah, the redirect status code that we talked about on Monday. 301 means what specifically? Moved permanently. So this is in contrast with 302, which happens to be moved temporarily. Who cares? Like, why are there these two separate codes, do you think, whose functionality is essentially the same? Good. If it's a 301 and thus permanent, the browser, if it's smart, it will cache that response. And the next time you, the human, try to visit the same page, you're just going to be automatically redirected without wasting the server's time asking the same question. Whereas 302 means it's temporary. You probably should check back with me. So upside is you save a little time. The user gets a response a little bit faster. Downside, though, is what? What's the downside of 301, do you think? Again, start thinking about corner cases and problems you might be creating by trying to be helpful for the... What's that? In case it reverts back. Suppose that you just decide to reconfigure your server, or you change the name of it or whatever. You know, it's not something you do commonly, but the day you do it, are you going to be tricking your users into visiting a dead end? And so you have to be mindful, especially if you're the person doing the web server configuration, not the development of the website. Maybe we should make sure both of these continue working for some number of days or weeks so that anyone in the world who had cached this response finally reboots their computer or quits their browser. So these are the kinds of corner cases to be mindful of, especially when you care ever so much about uptime and making sure your users don't hit dead ends. L, probably wouldn't guess this. This means last. This just means if you have a whole bunch of these rewrite conditions and rules in the same file, this is just one of saying, that's it. Don't bother processing anything else in the file. We want this redirect to kick in first. So find fault with this. I'm kind of looking at my own line here, and there's technically a bug, even though it's not likely ever to be encountered. How could I have been a little more rigorous with defining this, do you think? Specifically, I'm thinking about my pattern matching. It's not quite as robust or correct as I think it probably should be, if you want to be really nitpicky. Yeah? Sure, yeah.
I don't know if that would help, but you could add HTTP in front of www.
HTTP in front of www. Oh, good. So good thought. To put HTTP, it would actually break then, because HTTP host, the variable, is by definition, and you can only know this by reading the manual, does not contain the protocol. It only contains the host. How about if I point at the end here? What could I be doing better? Yeah.
A slash at the end.
So good thought too. Slash also, though, doesn't belong because it's part of the path, and the host is literally just the host. But it is something there. If you are familiar with regular expressions, it could be
something that corresponds to begins before it ends.
exactly. And for some crazy reason, you would like to think that, or it'd be a nice world if the caret symbol represented both the beginning and the end of a string, but the world chose $. So I should really put a $sign after the T here, because that would mean you have to literally match NET, and that's it. Now, why is that relevant? Well, it's probably not that relevant because I do not know of any top-level domains that exist today that that start with NET and have more letters after them. But there is this tendency now where the world is creating much bigger names. And in fact, if you pay like $100,000, you can get .google or .apple. But someone could get .network solutions. And as soon as we do that, then again, the pattern match is not quite right. But again, it has no real material effect, because if DNS weren't set up, the user would never reach me. But again, just a little thing to be mindful of, that it's not as precise as we could be. All right, so what is this? OK, that was really technical. Who cares? What is this really doing? Why would the user ever reach my website and not already be at www.cs75.net? What is the point of these 3 lines from a user's perspective, or really just big picture here? How else could you visit www.cs75.net, even today, with your laptops? Yeah? OK, FTP, but then this wouldn't even kick in, because this is just web, just port 80, just HTTP. How else can you visit the course's homepage? Yeah?
There could be an error in one of the DNS servers that's sending
OK.
someone to your IP address who doesn't intend to go to your actual site.
Oh, so that's good. So if there's a DNS error or there's just some maliciousness going on, you could be led to our website. And right, we did this Monday. What was the stupid little demo I did on the fly that made a certain news company look a little silly?
Change the name to CNN.
Yeah, right. I think I had davidnews.com all of a sudden, and we went there and we stayed there. And I mentioned at the time that CNN, if they just put like 2 lines of configuration in a file, they could fix this and immediately redirect the user to protect their branding so that it goes back to www.cnn.com. This is exactly the fix. Now, we're not doing it because we're worried people are going to come up with like fake CS75.com or stupid stuff like that, but just the simpler, what if they just visit http://cs75.net? Enter. We just decided as a course that, like most websites on the internet, we wanted to standardize, not on cs75.net, which we want to work, but we want to redirect the user so that they end up at www.cs75.net. Now, why? One of it's just, branding. If you want to, there's something to be said for just at least standardizing what your URLs look like, whether it has the www or not. But more than that, we mentioned briefly on Monday, and we'll revisit this in time, the cookie issue, whereby if you do have a subdomain, you can then isolate cookies to be part of the www subdomain, and they don't have to be global to your whole domain name, cs75.net. So in other words, all these lines lines are doing for us, and these are literally the lines we use on our own website. If I go to http://cs75.net, enter, where do I end up? Well, a couple places. One, I end up at www, just because. But I also end up at the SSL version, also just because. And then this is just because we're using MediaWiki, software that automatically makes the default page called main page for no good reason. So there's a few things going on there. So you can infer from this, though, how can you enforce use of SSL on your website? Suppose you're a bank. Suppose you're Gmail these days, and you want to force users to stay on HTTPS, even if they visit HTTP. How do you do it? Well, it's pretty much the same trick here. But rather than check the host name, which is not the problem now, you want to check SSL. So what you can really do in this case is instead a line like this. Rewrite cond HTTPS not equal on. So this is a slightly different syntax, but this is a different condition we could use that asks a different question. If the environment variable called HTTPS is not equal to on, what's the implication? It means it's off. And so what should you do? Well, if the next line is that same rewrite rule, you will redirect the user. So this is how you enforce SSL. This is one way you can enforce SSL on a website. Yeah?
And so this checks for every page. So say someone went to like wellsfargo.com/banking. That
Exactly.
would still work, and it would send them to the HTTPS.
Exactly. This will work for every page on the website because we had that additional use of the capturing parentheses to ensure that they don't just go back to the generic homepage, which is just annoying, at least in my experience, but rather they go to / whatever they were at. And this gets installed, to be clear, either in that file called http.conf, but as you'll also see, there are per directory configuration files that Apache supports called .htaccess files, literally just a text file called .htaccess, and that syntax looks very similar to this, but you can't necessarily do everything in an htaccess file that you can in the main server configuration. It depends if people like us, the system administrators of a website, let you put certain commands in a directory. So you can use htaccess files to password protect directories, for instance, to change MIME type, so to speak, some fairly arcane details, but this is one of the most compelling. And there's actually another one. Facebook, if you're a user, almost many of the URLs end in what file extension, as we said on Monday? So .php, just because. Like for historical reasons, they still use PHP for a lot of their front-end stuff, but there's no technical reason to expose what language you're using on your server. In fact, it feels like it's just a waste of 4 bytes, right? Why bother sending .php when it's strictly not necessary? And frankly, it's very Web 2.0 these days to have cleaner URLs, prettier URLs that just don't have cruft like file extensions. These http.conf and also htaccess files can also be used to let you avoid ever putting .php in your URLs. Your files on your hard drive can still be called hello.php, but the user could just visit /hello, and using mod rewrite, you can essentially tell the web server, if the file /hello does not exist, look for /hello.php, and if that exists, serve that up instead. Yeah?
No, nothing.
Okay. So a lot of power here. I will say, too, this is one of the things that frustrates some people, including myself, the most, because the slightest syntax error anywhere, if you get the permissions of the file wrong, your whole website can break. So it's a lot of power and a lot of trial and error and a lot of Googling sometimes to solve these problems. All right. Any questions? No? All right, so where can you use stuff like this? Well, next week when we start talking about the first project, we'll introduce this appliance, this virtual machine, in which you will have your own version of Apache running. But certainly after the course, or even during the course, if you want to experiment with other approaches, it's actually very easy to get LAMP onto your own computer. You don't need to pay for a web host. You don't need to set up a Linux computer. You can do it on your own Mac or PC. In fact, Mac OS these days comes with Apache, comes with PHP, comes with Python, comes with Perl. A lot of support for web programming related stuff built in, even though you sometimes have to run some commands to actually enable it. Your laptop is not a web server by default, even though Apache is in there if it's a Mac. Windows tends not to come with as much software along these lines, but either way, there's some packages packages, this is one of them, XAMPP, that makes it pretty easy to make a web environment on your own computer. Not necessarily for serving content to real users. We had that discussion on Monday that getting users from the outside world to your home with your cable modem and all that is non-trivial, and your ISP might not even let you or like it. But for development purposes, you don't need an actual web server per se. You don't need to pay anyone to start doing web development. You can do it on your own local hard drive, even if it's not static content, HTML files, but it's actually dynamic with something like PHP. So XAMPP is just the product name for free software that includes support for Linux, Mac OS, Solaris, and Windows. So it doesn't matter what OS you have. And it installs for you Apache, MySQL, PHP, and also even Perl, which is the other P in LAMP sometimes. Or actually, no, that's the P in XAMPP, not in LAMP. So what does this mean? It means you go to their website, which is, you can just Google XAMPP to pull up their page. You can install this software, and ideally, you then have some nice documentation locally, and your own database, your own web server, your own installation of PHP, so you can do all your development locally, which is nice because it's super fast. And it means you can work in a cafe or whatnot without even having internet access. There are some corner cases. XAMPP hasn't been the easiest historically to set up. Sometimes it doesn't quite work on everyone's computers, which is why we actually transitioned to the VM approach, where we can guarantee that everyone's environment is the same and works correctly. But certainly moving forward, when you no longer want to rely on course-provided software, realize this is a nice local development option as well. And it similarly lets you configure most anything you would like. Any questions then? All right, that feels like a good point to take a 5-minute break. And when we return, why don't we dive into PHP and actually finishing the back end of something like Google.com. So let's take 5. All right, we're back. So just a couple of details. You should have or should soon receive an email invitation from the course's discussion tool. We'll post a link and an announcement on the course's homepage to explain where to go and how to go if you did not receive such a link, but it would have gone to this email to the email address with which you registered for the course, FYI, in case that's not an address you use quite commonly. But again, more details on the course's homepage by tomorrow. And let me introduce another of the course's TFs, Alan, who, if you wouldn't mind coming up close to my microphone, if you'd like to say hello to the class.
Hi, everyone. My name is Alan. You can call me Alan if it's easier for you. And I'm here to take your questions and help you out with anything you need.
OK, excellent. Thanks. And Peter, who you met on Monday, will be back shortly this evening. And once the lecture wraps, we'll dive into section, which again will be an opportunity for slightly more intimate Q&A to go over concepts that might be a little more abstract. And particularly once the first project is released, which will be on July 9th is when the first one will go out. It'll be an opportunity particularly to focus on the project and get direction and guidance and design tips on those. So more on that to come. All right, so time for some PHP. So recall that we talked briefly about some of the basic UI mechanisms that browsers allow. Radio buttons, text fields, text areas, checkboxes, and the like. And these really are going to be the fundamental mechanisms whereby we go from static websites with just HTML and CSS to dynamic websites with some kind of server-side intelligence that does something based on user input to produce dynamic user output. So these days, thankfully, the web's getting more interesting and sexier than some of these more old school UI mechanisms, but even the fanciest of autocomplete widgets that you see and calendaring things where you can choose calendar dates and the like are still built on top of these, but all the more stylized these days with JavaScript and with CSS. And so we'll look at some of that fancier use of input mechanisms in a few weeks when we get to Ajax and JavaScript itself. So here is a representative snippet of Google. Recall that on Monday we started implementing the same interface, even though it was all black and white and text, but we did have a text box and we did have a couple of buttons, and when you click that submit button, you actually ended up initially nowhere. Right? We ended up on my same file, which was not dynamic at all, but then I went in and changed the action attribute so that we actually submitted to Google. So technically we cut some corners and didn't implement a dynamic website ourselves, but we did look at the basic mechanism whereby form input becomes get requests, or an alternative to get is post. For those familiar, what is one or more of the fundamental differences between using get, capital G-E-T, versus post, P-O-S-T? Yeah?
Oh, well, get's actually going to include what you entered in your form in the URL.
OK.
And post is just not going to do that.
OK, excellent. So get requests will have state change in the URL itself. And that's exactly what we saw on Monday with Google, where we had question mark. And what came next? Question mark, Q equals whatever Harvard, whatever I happen to type in or the user types in. So post does not do that. So that's a nice distinction, but what are some more distinctions? Or what would motivate you using get versus post if functionally they could be the same? You could still get search results, for instance, even though Google, as an aside, does not support post. What else should drive you to get versus post? Or vice versa? Yeah?
Well, if you're on a site that tends to deal with uploads, you're going to want to use post because it has special ways to deal with large files.
Excellent. Yeah, so GET requests are not so great for things like file uploads, photo uploads, right? If anything, conceptually, this just makes no sense. How do you upload a file in a URL? Now, technically, you can encode it using something called base64 encoding, where you convert the binary image of zeros and ones to A's and B's and C's and 1, 2, 3s and so forth. But the other gotcha is that most browsers have a length on the maximum length of the URL. Unfortunately, this is not standardized, and it's barely even documented. But the rough rule of thumb is if your URL is several hundred characters long, it's probably too long. And a reasonable cutoff is something like 1,024 characters. You're definitely pushing your limits. However, it's completely browser dependent. Some browsers support 8,000 character URLs, 1,000 character URLs. But the takeaway is that really you have to deal with the lowest common denominator, whatever that is. And so anytime your URLs start getting long, it's probably time to rethink your design and start using something called AJAX, which again we'll look at, or using post. Post does not have a limit. In fact, one of the upsides of post is that it, in the HTTP headers, will tell the server how big the file or parameters are that are being posted, so to speak, so that the browser knows when it's received everything. So the browser figures out, okay, this is like a 5 megabyte photo, so I'm going to tell the web server through the headers, expect 5 megabytes, and then what the server gets is below all the headers is all of the crazy zeros and ones, or equivalently A's, B's, C's, 1, 2, 3s, but it knows where they stop, so it knows when it's received the whole photo. So post is great for that. What else is post compelling for? What other use cases besides file uploads? Again, put on your paranoid hat. If you're using get, what are you at risk for instance? Yeah?
Somebody actually sniffing what the user sends.
Perfect. So and what might the user send that could be sensitive?
I mean, you wouldn't really send a password or a
Good.
username with a get request.
Okay, good. So sending usernames, passwords, credit card numbers, anything that's arguably sensible probably should not be submitted via GET because it ends up in the URL. And why is that bad? Well, fundamentally, it's still being sent to the web server, and if it's over SSL, it's at least encrypted. However, it's not encrypted from your family members or your friends or your roommates who might sit down at your same computer, and you know what you can do with most browsers today is browse through the history, right? And if it's in the URL, that means it's going to get logged, and it's going to end up in autocomplete until the cache is manually cleared. It's just too easy then for someone to find it, and it's also going to end up somewhere else. Even though it might be transmitted over SSL, so random people on the internet or Starbucks can't see it, once the server gets the request, many servers, as you can maybe infer from the http.conf configuration file earlier, have logs. And what tends to get logged in logs? Not posts, because they could be huge, 5 megabytes and whatnot, but typically what are logged in logs? GET requests, including the URL that was visited, which means any website that's ever used GET for password authentication or credit card submission, which would be rare, but could happen, especially if the person doesn't know what they're doing, it's ending up in the logs, which means some random person's unencrypted log files has all of your sensitive information. So in short, anytime something is big or anytime something's sensitive, GET is not the way to go. However, that would seem to suggest, fine, just use post all the time, right? Just avoid all these issues together. I don't have to remember what the difference is. But what's the downside of using post? Based on your own, maybe even non-technical user experience. What's a downside? Yeah.
Can't copy paste the URL.
Yeah.
Mail the book to your friend.
Perfect. You can't copy paste the URL. Completely reasonable concern, especially from a user experience perspective, because very reasonable for someone to want to copy the URL, say, oh, check out this book or check out this link, whatever it is you're looking at. And it's actually pretty infuriating when the person who receives the email says, oh, I only see their home page, because they've just redirected them because of a number of things. One, the state that was necessary to remember that book, the ISBN or whatever, was not in the URL because they were using post. Or it's even worse, some websites, even I think the Harvard Coop does this, when you navigate around their website, the URL similarly doesn't change because the information is being stored, as best I can tell, in their session cookie, something we'll talk about next week or later tonight, whereby it's only remembered by the server thanks to a cookie where you are, which means even you can't bookmark your own pages that are of interest to you. So in short, horrible design, and some websites are very much guilty of this. So anytime you want the user to be able to save state in a URL, rather in an email, or just with the back button too, it's helpful to make sure it is in the URL itself. Of course, there's another reason. This is getting better these days with modern browsers, but typically with posts, if you click reload, you'll often get prompted. And the website will say, or the browser will say, are you sure you want to resubmit this form? So there's also issues of resubmitting forms and whatnot that are typically bad. And so one of the things that's gotten more common these days to avoid people accidentally checking out twice or buying things twice on an online store and having that message say, wait a minute, are you sure you want to submit this form? What you can often do is once the user does a post because they've uploaded something or they've bought something, what you then do is immediately redirect them with a 301 or a 302, which only use gets. You can't use redirects to repost somewhere else, FYI. Then the user, if they accidentally hit reload or hit back in their browser, they're only going to go back and forth between a GET request, not a POST. So you can also discourage the user from submitting a form again. And there's other protections you can put in place, but that's another reason too. If you want to avoid resubmission of forms, sending a GET via redirect can be one level of protection against that. All right. So here we go with PHP. This is going to be a fairly rapid tour of this because, again, the course does assume non-trivial prior programming experience. So this is another detail, too, where if you find yourself, what is programming? Again, we should have a conversation right after class or with Malan or with Peter if you're more comfortable about what your own background is, because we're going to start talking about things like arrays and hash tables and associative arrays. And if this is all new to you, it's definitely going to be a bigger challenge, but we've certainly had students do it before, so use your judgment along the way. So one of the best things about PHP is its documentation, to be honest. It's actually fairly user-friendly, very nice to navigate. And so let me just pull up an arbitrary example of kind of a boring function, but one that's commonly used. If I Google PHP date function, I can go up to a representative documentation page here. And just to give you a quick tour of something you'll see much more when you dive into the course's projects, along the left-hand side of the website is a list of all of the related or available functions. PHP is actually not this slow of a language usually. Let's try reloading. OK, I cheated. So actually, there's an interesting lesson there. So actually, let's try this rather than just give up on this altogether. Let me see if we can. Oh, damn, now it worked. So I was going to pull up Chrome's network tab. We could look at exactly what was hanging there, but it seems to have resolved itself. So quick tour then of the page here. So on the left-hand side is all of the related functions, just FYI. A little overwhelming at first, but the reality is for this class, and really in general, you're not going to need to know every one of these functions. Just looking it up on demand is useful enough typically. On the right-hand side is the canonical layout of a function. So it tells you first what version of PHP supports this function. This is actually important. Not so much when you control your own server, because odds are you'll be running yourself if it's your own server. Pretty recent version of PHP, 5.1, 5.2, 5.3, 5.4 are fairly recent incarnations, with 5.4 the latest. But there are some web hosting companies that might still be running PHP 4. Not terribly common, but you will lose a huge amount of functionality, including object-oriented programming support, if you are on something as old as PHP 4, just FYI. So what does this function do? It formats a local date and time, which means if I give it a string like h:(m) for hours: minutes, or something like that, it should return to me a formatted string like 3:00 p.m. or something like that. So that's what it does. It gives me the current time, or converts a numeric timestamp to a date. So here's how you parse the signatures. This means it returns a string. This means it takes a string as its first argument, which is the format. Any variable in PHP, as we'll see quite a bit, starts with a $. Square brackets in documentation means it's optional, which means if you want to override the current date and time, you can pass in a numeric timestamp. For those unfamiliar, a timestamp in many programming languages is the number of seconds since January 1st, 1970, the so-called epoch, and then you can override the default behavior. Useful if you've stored timestamps in like a database and you want to display them in some human-friendly way after the fact. All right, this returns a string formatted according to given format string, ... Here's just some more detail on the format. So the format parameter can apparently be a quoted string containing all of these various placeholders, D for day, J for day of the month without leading zeros, and so forth. Memorizing this is not a good use of any human's time, but looking it up is reasonable. Let's just scroll down past all of that. Timestamp does what I promised. Return value returns a formatted date string. If you do something wrong, it goes on to explain that there's an error. And then let me scroll down here. The examples, frankly, is where my eye is typically drawn most immediately. So if I take a look here, this gives me some little cheat sheets. If I want to print out echo date, quote unquote, L, for whatever reason, L denotes the day of the week. If it is Monday, it would print Monday. Today, it would print Wednesday dynamically. Here's a more complicated date string that they claim will print out this, and so on and so forth. This is the kind of thing that this function does. But the takeaways for our purposes now is just PHP's documentation is always structured in this way. Summary of the function up top, description of the parameters, some version notes in case you need to beware what version of PHP you have, example 1, example 2, example 3, and then at the bottom, there's generally some pretty intelligent discussion on the comment threads that are there. It's not really crazy talk. They seem to moderate it quite well. So you actually see people sharing useful code for common workarounds or common tricks that someone might want to do related to the date function. So in short, the documentation will be your friend. And what we will do in lecture is not go through mind-numbing tours of the various functions that exist and so forth, but focus much more so on the concepts, on the syntax, and on the overall framework so that you know as you dive into how do I do this, where it fits in big picture in terms of a project. So PHP is an interpreted language. What does it mean for a language to be interpreted? Or what is the opposite of an interpreted language, even though they're not truly, literally opposites? Yeah? A compiled language. So a compiled language is something like C or C++ or language that has source code written in English-like syntax, but you have to run it through a compiler like GCC or Visual Studio or the like, and it outputs what's generally called object code, or more specifically zeros and ones that are patterned in a way that a CPU, like an Intel CPU, understands. An interpreted language skips that step, essentially, whereby instead you write the source code, and then you pass your source code through what's called an interpreter instead of a compiler, and an interpreter essentially reads that language that you've written, the source code you've written, top to bottom, left to right, doing line by line exactly what you tell it to do. So the upside is there's no intermediate step. You don't have to run the compiler, then run your program. In an interpreted world, you just run your program through the interpreter, and it's that. It's one step instead of two. But what's a downside of the fact that it's interpreting it line by line as opposed to converting it to zeros and ones? Performance, typically. So compiled languages tend to be faster because you're spending more time in memory and disk space up front to convert source code to object code, zeros and ones. But once it's zeros and ones, it's super ready to be read and understood by the CPU. Whereas an interpreted language typically needs to be literally interpreted again and again. And every time I call the date function, DATE needs to be parsed or read and then converted effectively to the underlying functionality. Now, there exist compilers of sorts for PHP and for other interpreted languages and what are called opcode caches. More on this at the end of the semester when we talk about scalability, which simply means for now that smart web servers and interpreters will do the interpretation once, convert it to some intermediate format, and then save that intermediate format, which in the PHP world is called opcodes, OPCODES. And this just means it will skip that step the next time around. It's not quite compiled, but at least it's better, it's a closer approximation to it. Frankly, it's a nice thing with interpreted languages because you don't have to go through that annoying step of recompiling every time you make a change. You can interact with your code a lot more fluidly. It just saves some steps, especially for large projects, which might have large numbers of files and lines of code to actually compile otherwise. So some upsides and some downsides sides. If you're crazy popular, like someone like Facebook, Facebook actually has a framework called HPHP, which they released open source a while back, which actually compiles PHP down to C++, which is then compiled in turn to object code to get maximal performance out of the code that they write. And this is motivated by a number of things, but among the things they discuss publicly is this way, PHP is fairly omnipresent. It's a fairly easy language for people to learn, especially coming out of college and the like. So it means they can have their developers using a language that's fairly easy to learn. They probably already know it, and they can then defer the performance details that are typically associated with the language to some of their more advanced engineers who can then take PHP code down to something that's even more highly performing. So among the options that exist these days. So a lot of the arguments you might see on the web about performance of PHP versus Ruby versus Python versus Java versus this, there are many, many different technical solutions to the performance question, and a very valid heuristic, I think, when choosing a language, whether it's going to be PHP or another, is what you already know and what the cost is to you, the developer, to learning something else, what your friends know or what your colleagues know, and also what tools exist to mitigate any of the prices you pay to use something like an interpreted language. So suPHP. This is something that will be installed in the CS50 appliance. It is installed on some web hosts, but not nearly as many as would be good. So suPHP is substitute user PHP, and it exists to solve the following problem. When you have a web server, you have software running on it that listens for connections on port 80 and so forth. Years ago, most such servers ran as a username called root. Root is the administrative user, and running anything as root is generally bad. Why? Yeah.
Well, you can like destroy your computer.
You can destroy your computer. How? Be more specific.
Well, you can remove like files that are essential to the operating system.
Good. So if the root user has full-fledged access to the system, if you make a mistake in your code, if it's a web server and you're running web code, and you make a mistake and you accidentally delete the wrong directory, that is permanent. Like you can touch anything on the system, including the password file, which even though it's encrypted, should not generally be shared with the world. So in short, running anything as root puts you at risk because if what root is doing is buggy, and odds are, you're a human, you err, you're going to write buggy code sometimes. That means who's running the buggy code? The most important user on the system, which means your entire machine could be compromised if you screw up. So finally, the world years ago got into the habit of at least running web servers in particular as different usernames. Sometimes nobody, literally, the username nobody, or www, or Apache, or HTTPD. Doesn't really matter what it is. It matters that it's not root. But some problems arise, especially in this popular world these days of vhosting and web hosts, commercial web hosts. Because think of this. If you are customer A and there's a customer B, and you have someone like DreamHost or the like, you each have accounts with them, and you have your own usernames and passwords, and you have your own home directory, so to speak, where you can store your code. But the web server runs under username Apache, for instance. Apache, again, being the web server software. In terms of permissions, Apache is not you, obviously, because you are A or you are B, so you have different usernames. But if Apache is the web server, and the web server needs to obviously be able to see your files in order to serve them up, what kinds of permissions do your files need, if you're familiar with Linux file permissions, or Windows, or really file permissions in general? Your files have to be what's called world readable, typically. You can do more fine-grained permissions, but the reality is on most systems, the easier approach is you're told to chmod your file 644. More on that in the future. But make your files world readable. Why? Because you don't really need the world to read them. You need the web server to be able to read them, including especially your PHP code, which we're about to start writing. So what's the implication, though? There's a few things. If your files are world readable so that this middleman, Apache, can read them, that's great. It makes the website work. But it also means that someone else can read your files. Who?
That would probably be the other customer.
The other customer, customer B, right? Because world readable is world readable. Now, if your files are being served up on a web server, that means you can see your files at URLs like /hello.php. So that means anyone on the internet knows what your files are called. So the other customer, because he or she can log into the same server, can just enter your directory, and even though they might not be able to see all of your files, if they know what they're called, they can then definitely see your files by just using a text editor or some kind of program that just opens these files. Now, that's not such a big deal for JavaScript, for CSS, Because frankly, who cares? That stuff is by nature of JavaScript and CSS going to be sent to the browser and the whole world anyway. And you might try to obfuscate it, as we'll discuss in a few weeks, with minification and hiding things from users. But you can't really protect your intellectual property when it comes to JavaScript and CSS, because the browser and the whole world have to see it. But PHP, you might have put a lot of heart into it, and you've put a lot of intellectual property into your PHP code, which is really the secret sauce of your business or whatever. But now the web server needs to be able to read it, as can any customer. So now you're at risk of the customers seeing all the hard work you've done. In fact, what might your files contain out of necessity, if familiar with databases and the like? Yeah?
Well, the PHP would need to contain the name of the database and the password.
Exactly. Things like usernames and passwords for databases, for caching engines, for Facebook APIs, whatever it is, your PHP code might have somewhere inside of it variables that need to be there, but you don't need customer B being able to see it. So in short, running a web server as Apache is great for security of the whole site, bad for the security of customers A and B and C, who probably don't even know each other and certainly shouldn't trust each other. So thankfully, there's a solution here, and it comes in different forms. One of the solutions for PHP is suPHP. In the suPHP model, customer A's code is executed by a username called A, the same user's username. B's code is executed by username B. In other words, the web server sort of magically transforms itself into user A when it's time to execute A's code, and transforms itself into user B when it's time to execute B's code. Which means if you screw up and have buggy code and you're customer A, whose files could you possibly delete under this model? Only your own. And that still might be unfortunate, but at least you're not compromising anyone else on the system. And it's your own fault if you delete your own files, but it's a good thing that you can't delete anyone else's files. This also solves another issue. If your website is like a commercial website, even if it's small with only hundreds or thousands of customers, and those customers need to upload files like photos or videos or stuff that's not meant to be public in the Facebook sense, but fairly private, at least in the limited privacy sense. So the upside here is when a user uploads a file now, and the web server is using suPHP, that file will be saved on the disk as owned by user A. And B's files will be saved as user B. By contrast, in the other model, where everything gets run by Apache, who saves the files? Apache, which means Apache owns the files. And that means the only way to ensure that they can be accessed subsequently is to make them world readable, which means all of the new content your users are uploading is going to be readable by customer A and B and C and D on the system. So in short, this is good. And this is not a feature that's typically advertised significantly by web hosts. I don't even know if DreamHost does it these days. I'm going to guess they don't, because we didn't see mention of it, but don't hold me to that. You might want to dig a little deeper into the fine print. But if you are using something like a virtual private server, you can also avoid this issue altogether, because at least if you own the whole server, even if it's a rented virtual machine, at least there's no other customers on the same server. So again, something to be mindful of, so that when you pay $8.95, $5.99, whatever it is per month, again, you're getting what you pay for. And if you care about your intellectual property and the security of your site, these are the kinds of questions you should be mindful of asking or reading up on before signing up. So suPHP is something that will be installed in the appliance. So for those who'd like to read up on the language itself, this week there'll just be some recommended readings of sorts. Realize that there's some good tutorials online. And again, if you have a programming background in any syntactically similar language, some of this might even be boring, which would be great, because it will walk you through for loops and while loops and the like. So we'll just do a quick tour of some of the syntactic details tonight, but then focus on some of the higher level concepts that will be distinct to web programming. So without further ado, one of the more stupid details, but just put it out there because it's the first thing you see. Variables, again, start with $signs in PHP. And here's the rule as to what is valid. In short, I would choose variables in a sort of normal way, typically with alphabetical letters. But there are some other things you can use, like underscores and numbers and the like. But again, we won't spend too much time on this kind of level of detail. Data types. PHP is what's called a loosely typed language, which means the data types exist, kind of, but they're not readily enforced in the same way that they are in Java or in C or in C++. So what data types exist? Booleans, integers, floats, and strings. But when you declare a variable, you do not specify its type. It is inferred by the type of value you actually put inside of it. So if you say something like $x, because again, $sign means this is a variable. $x is a very boring name for a variable, but it's a variable. Equal sign, 1, 2, 3, semicolon, that data, the data type of that value will be integer, even though I didn't specify it as such. If by contrast I say $x equals 1.23 semicolon, it's instead going to be what? Yeah. Float, a floating point value, a real number. If you instead say equals true or equals false, it's going to be a bool. If you instead say quote unquote hello, it's going to be a string. But that type is not invariant. If you try to use a string in a Boolean context, you will get a lot of implicit conversions. So in other words, in an if condition, normally you would say something like if x equals y, or you would say if true, something like that. If instead you say if quote unquote hello, well, hello will be implicitly casted to a Boolean, and because hello is not the number 0, the Boolean value of hello is going to be true. So you can use strings even as truth values, which can encourage sloppy programming, and we'll see some examples of this, but it's also useful sometimes in that it's not as pedantic a language as something like Java, where you're constantly casting things back and forth. Yeah?
Can you perform string operations on integers or vice versa?
Good question. Can you perform string operations on integers and vice versa? Yes. They will be upcasted to a string in that case and become part of the string itself. And one of the motivations for this is that PHP from the start was really designed to be web-centric. And the reality is when you're writing web software, you're interacting with the user entirely via strings. Now, the user might type in 1, 2, 3, but as we've seen via HTTP GET and talked about HTTP POST, it's all text at the end of the day. There's no data type associated with an HTML input field. So even though the user might type 1, 2, 3, what's going to be sent to the server is quote unquote 1, 2, 3. And so the fact that there is this loose typing is reasonably consistent with what you're getting from the user anyway, even though, again, it can feel a little messy, and it is in some sense, but that's at least one of the original motivations for it. In terms of objects and collections, PHP has arrays, and it also has objects. More on those to come. It also has things called resources. Resource is something like when you open a file, what you get back is not the file per se. You get what's sort of like a pointer or a reference in C or Java speak, and that reference is to a resource, which is sort of like a special object that contains interesting information, the size of the file, your location in it, the type of it, and so forth. Details like that. Null is null. It's when you have no value there. You can have the value null as a placeholder, but variables in PHP, as we'll see, can also be set or not set. So null is an actual value. It doesn't mean the absence of a value. You can have the absence of a value, as we'll soon see. And then there's mixed. So mixed isn't really a type, but you'll see these things in documentation in particular. If you see on php.net documentation that says this function takes mixed, what does that mean? Well, it means it can take any number of different types. It can accept a string or a number. And this is where PHP is both handy but also a little sloppy, in that it's not strictly typed or strongly typed. Number means integer or float if the function doesn't care. And a callback is a function pointer. We won't spend too much time on those, but you can pass functions around by pointers or by references, generally known as a callback in this case. Another word on mixed. PHP is very common for its design of returning mixed data types. So it's very common in PHP for a function, even like date, to return strings. But if something goes wrong, it could actually return a bool. And what's it going to return in that case? False. So it's very common in PHP functions that 99% of the time it will return a certain data type, but it could return something very different. So learning to check for that correctly is good in the context of PHP. So I'll point that out along the way as well. So now some special variables before we start writing some code. So in PHP, there are special global variables that are called superglobals. They are in scope, so to speak, everywhere. In any line of code you write, so long as it's executed by a web server, you have access to these variables. They start with $signs, start with underscores, and then all caps. So $_get is a variable. It's going to be an array. It's going to be an associative array, aka hash table, aka not really an object, but it's a key value store. What do you think is in the variable called $_get? Take a guess. Yeah.
All the things that are in the URL that perform send.
Exactly. So Q equals Harvard, foo equals bar, baz equals quux. Whatever the user submitted via the form is going to be handed to you on a platter, so to speak, in the form of this variable, so that if you want the value of Q, you just have to look inside that variable. And this is one of the things that's compelling about PHP. In contrast, language like Perl, which was very popular years ago for web programming, you had to jump through hoops or use an external popular library to actually parse the HTTP requests to get access to the keys and values. PHP and frameworks like Django and Ruby on Rails make this so much easier these days. And PHP does this through these superglobals. $_post, probably guess what that does. Anything you post ends up in that array. $_files is great too. If you do let the user upload photos or whatnot, you're handed the files in the form of an array. You don't have to parse it or figure out how to deal with file uploads yourself. Super easy in that sense. Some of the more esoteric ones now are server and env. Server contains things like the user's IP address. Their user agent. What was user agent? Yeah? The browser and the operating system, that cryptic string that is apparently being sent every time the browser visits you. Env is in for environment variables, rarely used, but it gives you access to lower level details on the machine. Cookie is nice, and we'll come back to that next week, but cookie stores cookies, key values that you might send or receive from browsers. $_request has all of the interesting details about the user's request. What path did they request? Was there a question mark in the URL with parameters? It gives you access to the raw details before they end up in a more user-friendly place like get and post and cookie. And session is one of the most powerful ones, arguably. It is the thing that allows you to implement state and implement things like shopping carts. Even though HTTP, as we sort of began to discuss on Monday, is stateless, and that as soon as you visit a page and you disconnect from the server and the page is loaded, you no longer have a connection to that server anymore, via cookies, you can remember, or rather a server can remember that you're logged in. And we likened the cookie on Monday to like a hand stamp. And what is session? Session is this amazing superglobal in PHP that you, the programmer, can put anything you want in it, any keys and values, any numbers, any strings, any ISBNs of things users put in their shopping cart. And the next time the user visits your website, so long as their cookie hasn't expired, you can access that exact same data in $_session magically, so to speak. You don't have to worry about figuring out who the user is. PHP and in turn the web server do all of that for you out of the box. So again, another upside of a language like this. So let's actually see this in action rather than talking about it in the abstract. So last time, recall that we had this file. Let me go to CS75.net, lectures, where we posted the video and more. And in our source code directory, typically if we write some source code on the fly during lecture, I'll clean it up and then upload it the next day to the server if you want to play around so you don't have to write down code and whatnot. Or if we have some stuff in advance, I'll put it there. So this is from Monday. And we had this site, Google and Google Search. And when I submitted this, recall that if I searched for Harvard, enter, I ended up at oh, we broke it. I should fix it. I will fix this. Recall that I broke it at the very end of class by changing the value of Q to something else altogether. I think I said like QQQ or something random like that. So let's now, instead of using Google to do our backend, let's instead write the backend ourselves. So I'm going to go ahead and do this. First, let me grab this page source, and I'm going to open up our little text editor as before. And yeah, this is what I did wrong last time. So now it's back to Q. But this time, I'm going to change this to point at my own server. So then a word on the server. If I scroll over here, this is my CS50 appliance, the virtual machine that in a week and a half's time we'll start using as well. And it's a Linux computer. But more than that, even though it looks like a desktop with a little start-like menu in Windows, it's still a server. And I can see this as follows. If I go ahead and inside of the appliance, I visit Google, I see Google. But if instead I do http://localhost, localhost is the common name for a Linux computer when you're on the Linux computer itself. And this is true in Mac OS as well and sort of in Windows. Localhost refers to the computer you're on. So when I visit http://localhost, and let's just say /enter, I should see the root directory of the web server. So this is what I'm seeing. The fact that I'm seeing this page, and actually it tells us literally what it is. This page is used to test the proper operation of the Apache HTTP server after it's been installed. If you can read this page, it means the web server is installed at the site working properly but has not yet been configured. So that's great. That's exactly what I wanted to see. Some mentioned that web server's working, and now it's up to me to actually populate it with some data. Now I can do something else now. And these kinds of steps, if you're unfamiliar, we will explain in the before the first project. What I've done is right now is I've opened up a so-called terminal window. This is an old school black and white interface for navigating the contents of a computer. It's like the DOS prompt of yesteryear. Mac OS, it's the terminal window. Windows sort of has an analog in the command prompt, but it's not as flexible as on Linux and Mac OS. And I can do a few things here. Again, we'll document this more in the future, but this is the fairly arcane command for making a directory. mkdir space the name of the directory. And I'm going to go ahead and hit enter. And what that will do for me, ignore the control C, is I can now do cd public HTML, and that stands for change directory. And in change directory, now I am inside of this. So cd is like double clicking a folder in a modern operating system, which then opens a new window. So cd has now put me inside of public HTML. So now I'm going to go ahead and do this. I'm going to go ahead and run a command like gedit hello, or let's do google.html. Gedit happens to be a text editor for Linux, so it's like TextEdit, it's like notepad.exe, but this one's a little nicer in that it supports something called syntax highlighting, whereby my code will be colorized to be more user-friendly. So let me go ahead and copy what we wrote on Monday over here and paste it in. So this is what I mean by syntax highlighted. It's just pink and purple and whatnot, just to draw our attention to semantically the different parts of the web page. And now I'm going to go ahead and hit save. So Control S, or I can go to the File menu. And now let me go back to that terminal window. And again, I'm back in Linux here. And I'm going to go ahead and do ls. And notice I have a file called google.html. And I can do all sorts of commands. There's the cat command, which shows you the contents of files. There's the more command, which shows you the contents of files. I can do any number of things. I can accidentally delete it with the rm command. Don't do that. But I can do all sorts of things at the so-called command line that I could do with a mouse and a keyboard traditionally. So what's the takeaway here? Now that I have google.html, notice that I have it in my public HTML directory. But if you can infer, who am I at the moment? What's my username? Yeah. J. Harvard. So I am John Harvard. Why is that? Well, we configure this particular virtual machine with a generic username, John Harvard, so that anyone can use it, and so that in documentation and whatnot, we can tell you exactly what your username is. It just gets a little more annoying if everyone has unique addresses, because troubleshooting's harder and so forth. So just assume you've signed up for a web hosting company. They have arbitrarily told you your username will be J. Harvard instead of A or B. So now I'm in John Harvard's so-called home directory, the folder that I get for all my storage. And in there, I created the public HTML subdirectory, or folder. And in there, just to be clear, what's inside of public HTML at this point in the story? Google.html. So how do I visit Google.html? Well, I'm going to go open my Chrome browser. And rather than visit just localhost, I'm going to actually do this. http://localhost/tilde jharvard/google.html. So this is a convention on a lot of web servers. When you want to access a specific person's home directory, you do /tilde username /file name. You do not type what, apparently? Public HTML. So public HTML is implied by the fact that you're using the URL. So don't type public HTML in the URL itself. And now I'm going to go ahead and hit enter. And voila, damn it, broken. So what does this mean? First of all, what's the status code here? Does anyone spot it? Yeah. Forbidden. 403. You can see it in the tab at the very top. So that's one of those more arcane status codes. 404 is a little more common. File not found. File's there, but I'm forbidden. So just high level in English, what does this mean? Yeah. I haven't set the permissions. So we talked earlier about the idea of global permissions. Now let's frame this in a Linux context. And again, Mac OS is very similar. Windows isn't quite the same process, but the ideas exist on all of these platforms. So let me do ls for list again. This is like dir if you come from a Windows world. And I see google.html. Not all that enlightening. But I can do a long listing. So ls-l and then hit enter. So -L, for those less familiar with Linux or unfamiliar, is a switch, a command line switch or flag or option, whatever you want to call it, that modifies the behavior of the command, which in this case is called ls, enter. And now I see more output. What do I see now? I see first who owns the file, what is their group, and by default the appliance is configured so that there's a students group, and there's only one student for everyone called jharvard. But when you install your appliance, you're not sharing the same appliance. You all have your own copy of the appliance with one jharvard account. This means it is 424 bytes, which means 424 characters I typed into that file. This is when we last edited it. This is the name of the file. And I skipped the most interesting part, which is over here. Now, this is maybe a little cryptic, but RW generally denotes read and write. And what we have here is an indication of 3 types of permissions. So this is a very quick crash course. Again, you don't need to commit all of this to memory yet, because this will come up again in the actual projects. But what we've just done here is, let me actually copy and paste this. We have this sequence here. What in the world does this mean? Well, first I'm going to cheat, and I'm going to get rid of this one. The first dash is either a D if it's a directory, or a hyphen if it's a file, or something else if it's something else. But for now, let's just assume that directories and files are all that exist. So now there's this, and let me put some spaces in. It looks like we have a pattern of triples here. The first triple is the owner, so to speak. The second sequence is the group, in this case students, and then the last is the world. So what is the implication right now? The owner can read and write this file. The group, students, can read and write. That feels a little worrisome, but in this case, the virtual machine is on my own computer. There's a students group, but I'm the only student, so this is kind of immaterial. So it's not great, but not bad. It's not applicable at the moment. The whole world, though, can read this, and that's what I want for an HTML file. So it feels like my permissions are right. What else could be wrong then? Again, context is web server's running as Apache, or some username that's not me right now. But we have to give him access to it. Yeah?
Passed.
OK.
But could it have to do with the last dash?
The last dash? In this case, no. This is actually OK, and others would be possible. Technically, RW, R would be fine, or even RW, nothing, R would be fine. Point is that the world has to be able to read it. But what else does the world have to be able to have access to, do you think? The directory, right? We got to go one level higher. So how can I do this? Well, when I did ls-l a moment ago, I only saw the file. Let me do ls-al, which is all and long, or I can do this. You can combine switches typically in Linux, just for convenience, like this. al, now I see more. The first 2 lines are dot and dot dot. What does dot represent in a typical file system? Sure. Close. What does dot represent? Let me change the question. What does dot dot represent? Excellent. It means the directory above, so dot dot. So dot, though, by contrast, represents the current folder, the one that you're in. So dot is where you are. Dot dot is your so-called parent, which means the thing you're inside of, what the parent folder is, that your folder is inside of. So dot here refers to a directory called public HTML. Dot dot refers to my home directory. And now, I know what it is. Damn it. OK, so I'm going to have to fake this story slightly for just a moment. Everything is actually correct. There is another secret setting that I changed earlier in the week while playing with the virtual machine that explains this. It's a feature called SE Linux for Security Enhanced Linux, which disallows anyone, including John Harvard, from using the web. So let me see if I can quickly fix this. But this was a wonderful stroll down the diagnostic techniques that would have led us to the solution. Whoops. And we go here. OK. So, OK. So this is a detail you will not trip over yourself, because by default, what I just did is already done for you. It's just I disabled it while playing around the other day. This was an additional security mechanism called SE Linux, which comes with flavors of Linux like Fedora and CentOS and Red Hat, and is meant to lock down systems even more. But doesn't matter, because the story we told is still very much the same. In fact, I can simulate now how we could have created a problem for ourselves as follows. Let me go into this directory, and everything now looks correct. All of this is good because it means a few things. Google.html is readable by the world. What do you think X means for both dot and dot dot? Executable. Now, normally executable means like execute a file, run a program. But that's not the case for directories, because notice the D and the D. For directories, if a directory is executable, that means someone can get into it. They can't necessarily read it and see the contents. R is read. Execute means they can do the equivalent of CD into it. Or they can visit a URL that contains that directory's name. So the fact that this is X, and this is R is actually perfect. That's what we want. But I can simulate it being wrong. Suppose that by default, when I'd created this file, it looked like this. What's wrong now with this picture? What jumps out at you? Yeah.
It's only read by the owner, and no one else can access it.
Perfect. Only read writable by the owner. No one else can read it. That's a problem. So there's a bunch of ways to fix this, but the way we'll introduce for now is chmod, which is change mode, and then A for all, aka everybody, plus, what do I want to give everyone? R. So a little arcane, the syntax, but then this command gives it what we want. Change the mode of the google.html to give everyone R. The plus means give, minus means subtract. So enter, ls-al, and now that problem is solved. By contrast, if the directories looked like this, propose to me how we fix this problem now. Now my dot and dot dot directories are no longer executable, which means my file is readable, but no one can get into this directory via the web. How do I fix this? OK, good. A plus X for executability, and then the name of the file, which is or folder, which is dot, and I can actually put a space-separated list of these things on the command line. I can hit that, and now ls-al, we fix that problem too. Now suppose I goof, and suppose I do chmod a plus x google.html. You can maybe guess what's going to change. So think to yourself, what is this line going to look like in just a second? Now it has an X everywhere as well. Does this mean anything? In this case, no. It's an HTML file. It's a static file. Making it executable means nothing. And so is this going to break anything? No. It's just kind of wrong in principle. However, sometimes with PHP, your PHP files need to be executable. That is not the case on most web servers. Typically, they just need to be readable. And we'll now see some PHP. All right, so that was a lot of fun making google.html. Now let us pretend to implement a Google server. I'm going to go ahead and hit new. Let me copy this temporarily. So new file. I'm going to save this as server.php. So our very first PHP file, we're going to pretend to be Google for a moment. Enter. And now I'm going to start, I'm going to cheat here and say, you know what, I don't want to do any of this just yet. I'm going to just do something silly like coming soon. So this, I argue, is PHP. I name the file server.php. I claim you now know PHP. Now why is that? Well, in the world of PHP, you can actually commingle HTML and CSS with raw PHP code. So the fact that I haven't actually written any PHP code is actually kind of sad because this is not PHP, but this will still work. So let's actually take a look at what happens. I'm going to go into google.html now, which again we made Monday, and I've already fixed the query string, but I don't want to go to search on google.com now. I'm instead going to change this to server.php. In other words, when I submit this form now, I want it going to my own file just to see what happens. So let's go ahead and pull this up, and let me go ahead and type in Harvard again, enter. Wait a minute. Something's wrong. What did I do that's wrong? I did not implement this, certainly. Yeah.
You didn't refresh the page.
Perfect, right? Stupid mistake, right? Caching, right? The browser has to be reloaded to actually get the new copy of the HTML. So let's hit the back button, and let's then reload here. And now let me do a sanity check. I'm going to right-click and view page source. Now it's correct. This is what the browser is now seeing, server.php. So here we go. I'm going to search for Harvard now and hit enter. Problem. So this is a security feature that's actually provided by suPHP. Just for good measure, suPHP does not want your PHP files to be writable. Why? Because if you screw up, if the file is writable, you could change the file itself somehow. So we can fix this using what we know already of chmod, ls-al. The problem is that the PHP file is writable by group. How do I take away that W from my group, do you think? Yeah.
You use chmod and do g minus w.
Perfect. G minus W for server.php, enter. And now I do ls-al, and that's OK. And you know what? I'm going to do one more thing. Chmod, I'm going to do a minus r of server.php. And now here's the output. This is actually wrong now. I need to give myself back. So chmod owner, O plus R of server.php, ls-al. Whoops. Let's cheat here. So now what do we see? OK, so now I argue that this is sufficient for PHP. Whereas JavaScript and HTML and CSS and GIFs and PNGs and JPEGs need to be readable by all, I argue now that PHP files only have to be readable by me. Why this distinction? Why does this make sense in the context of what we've discussed thus far today? Yeah?
This is just a wild guess, but maybe the PHPs just run on the server, not by the actual user on the other side.
Perfect.
He's just getting what the PHP feeds to him, which is irrelevant in this case.
Exactly. So whereas static files like JavaScript, CSS, HTML, JPEGs are ultimately sent literally to the user to be viewed and seen by him or her, PHP is meant to be first interpreted by the server, and then the server will send the output of that PHP file to the browser. Now at the moment, we have kind of a silly example. Inside of server.php is no PHP code whatsoever. What's inside of there? Just HTML. So what's going to happen when I reload the page and resubmit that form, the web server, Apache, is going to realize, ooh, you have submitted a form to a PHP file. Why? Because it ends in .php. I am configured, because of the way the LAMP stack works, to interpret .php files using the PHP interpreter, which is just a program that understands PHP. Now, the PHP interpreter is going to look for PHP code. Anything that's not PHP code, it's defined to just spit out raw. So anything in the file, even if it ends in .php, if it's not PHP code itself, it just gets sent raw to the browser. So what is the user going to see in this case? Literally all of my HTML, because I haven't written a single line of PHP code yet. But the point, though, is that because it did end in PHP, the principle is the same. Only the web server has to be able to read that PHP file in order to interpret it. But who is the web server going to be running as for PHP files? Yeah? JHarvard. Because of the suPHP feature. Substitute user PHP means for any PHP file, substitute the user who owns the file so that the security mechanism we discussed is in place. So I'm going to go back to my browser. I'm going to go back to the form. I'm going to resubmit Harvard to my fake Google search, and now enter. Now, notice the URL is server.php, question mark, Q equals Harvard, coming soon. Now let's write some PHP code. One of the most powerful things you can do in a dynamic website is actually spit out what the user has done. So here's my PHP code, or rather, well, it's sort of meaningless because there is no PHP. Here's server.php. Instead of coming soon, let me do something like you wanted to search for colon. Let me do a bold tag, and let me really cheat now. Harvard, save this. All right, now nobody should be fooled by this. When I go back here, go back. Do I have to reload the form? No, because I only changed the server.php file, so you don't need to refresh everything. I didn't change to google.html. Let me go ahead and click Google search. Oh my God, we now have a dynamic website. I typed Harvard, and Harvard appeared on the screen. But not really, right? Because if I go back again, and I type in Yale, and hit Google search, OK, I'm clearly cheating. So let's be a little more genuinely dynamic. Let's go here. And I don't want to spit out Harvard, but based on the discussion of superglobals earlier, where in the world can we find what the user typed in for Q? Yeah. Go ahead. Yep.
Yeah, in the get super.
In the get superglobal. Yeah, so let's do this. We now need to insert the value of that variable. And you might just want to do this, $_get. Here's the syntax for going into a superglobal. You do square brackets, quote unquote, the name of the thing you want to get, close bracket. All right, so this is a superglobal itself, but it's more specifically an associative array, otherwise known as a hash table, hash map, whatever you're familiar with. And that means you index into it using not numbers, but words or letters. And what you get out of it is the values. So in this case, we should get back HARVARD or YALE. But not quite. So let me try this just to prove that I'm wrong. Let me go back here, research. OK, clearly not what I want. But I need to tell the server, here is PHP code. Otherwise, it's just cryptic-looking English. The means by which I do that is I have to enter PHP mode, open bracket, question mark, PHP, space, and then on the end, kind of the opposite, question mark, close bracket. If you've come from the world of ASP in Windows or JSP in Java, you might have seen similar tags. This just means enter PHP mode, do something, exit PHP mode. So let's see what the end result is here. Let me go back to Google, reverse, Google search for Yale. Interesting. What is missing here now? What did I do wrong? Yeah?
You have to actually send the value of the get.
Exactly. So think about any programming language you know. Generally, if you want to print the value of a variable, it is not sufficient just to write the name of the variable in your program. Echo would work. We have a couple of options here. We can say echo, literally. We can say print, and then we can do parentheses to make it an actual function call. I'll go with this one for now, but echo is also a viable option. And now we're explicitly telling the interpreter, print the value of this variable here. So let's go back to my browser, go back, resubmit Yale, and now we have some dynamism to it. Yeah? Is there a difference between echo and print? Not really. Print is a proper function. Echo is a language construct. The crazy people on the internet have done benchmarks comparing print and echo, and every blog post I've ever read pretty much says they're equivalent. Now, except for microseconds or milliseconds if you're echoing millions of things, but for all intents and purposes, they're the same. So we can do something else here. And now this is a religious thing that I'm sure some people on the internet will hate me for saying, but I've always thought this is an atrocious construct for saying enter PHP mode. And indeed, PHP also supports what are called short tags, open bracket, question mark, and that's it. Now, there are corner cases you can get into, and if you read the crazy religious debates online, you'll see that one of the reasonably compelling reasons is that if a web server is not configured with support for short tags. This is a short tag, because why? It's shorter than what I previously typed. Then you do run the risk of having your raw PHP code transmitted to the user as though it's just HTML or the like, at which point you've disclosed the sanctity of your intellectual property, or worse, your usernames and passwords. So that's kind of legitimate. But if you are running your own web server and have control over the short tags feature in a file called php.ini, which is a config file I think we mentioned briefly on Monday, that will be on the appliance for you to tinker with if you want. Frankly, I just think there's an elegance about the symmetry of this. But typically, when you're writing code that won't necessarily run on your own server, but could be posted as open source code, or you're writing it for a corporate project where you don't have control over the web servers themselves, the first way I did it with open bracket PHP is the preferred way, because it's more portable, it's not going to break. Because the worst thing is if you download code that someone else has written and it's all short tags, and your web server doesn't support short tags, and you might not control your web server because it's a third-party web host, it's a pain in the neck to go through thousands of lines of your own code changing your short tags to long tags or vice versa. So just FYI, you'll see both tricks online. So this is nice, but can we do better than this? Well, let's actually try something a little more general. Let me go in here instead. Let me create a new form. And let's do a few different data types this time. Let me go ahead here and paste this in just to get us started. And then I'll have a registration form. And center Google registration. Again, we'll do this time we'll do register.php. And let's do a few things this time. I'm going to do input name equals name. And I'm going to say, just do this quick and dirty for a registration form for like a conference or a student group or something like that. Input name equals name, type equals text. And now let's do a line break here. And let's just do another something here, like let's do gender, and let's do this checkbox, or vector radio, and for something like gender. And then I'll say value equals m for male, and I'll say m here, and then I'll say over here, input type equals name, nope, gender, nope, name equals gender, type equals radio, value equals f, and now I'll put f here, and then should we do one more? Let's do one, just a simple drop down here. Let's do a select, name equals state, close select. Let's do this here, option, value equals, let's say, Connecticut, close option, and Massachusetts. So our registration form, for whatever reason, will only support people from Connecticut or Massachusetts, just so we don't get bored typing them all out. OK, so I've made a very quick and dirty form in, sadly, a file called google.php. So I'll restore that later so you can have the original code back. Let's go ahead and save this to something else. So register.html. OK, so now let me pull this up in my browser. Server is going to change to register.html. OK, so there we have pretty atrocious looking website. And in fact, I've omitted one of the more important pieces. So what do we need? Yeah, it'd be nice if we had a submit button. And so let's go in here, input type equals submit, value equals register. Close bracket, reload. OK, so there's our very simple website. It's a little more interesting than our fake Google site, because at least now we have a couple of user input mechanisms that we didn't have before. So now, let's now look on the back end what we're going to get. So first, let me fill this out as a sample. David, male, we'll change this to Massachusetts. And now I'm going to click register. But let me zoom out so we can see the URL change. Register. And now register.php was not found on the server. But that makes sense, because we haven't created it yet. So let's go ahead and do that. Let me go back to my text editor. And let me copy this temporarily, make a new file, paste this in. We'll call this register.php. And I want to say here, registered. And we'll say something like hello, open bracket, print, $_ get, name, close bracket there. So let's take this one step at a time. First, I'm just going to say hello to whoever it was that registered. OK, so let's go back over to the browser, go back, resubmit the form, and damn it, same bug again. So quick, how do we fix this? Writable by group, that was a problem. Chmod G minus W of register.php. OK, fixed. Let me go back here and notice new status code 500. 500 is generally the worst. It means you really did something wrong. All right, so let's go back here. Let's reload the form, and voila, hello David. OK, so some progress there, so that's good. And let me introduce one other syntactic trick. Frankly, this isn't the prettiest thing, printing out a single symbol there. There's this trick you can do with short tags, which is very compelling. If you want to insert the value of a variable, you can put open bracket question mark equal sign with no space in between them. So just to confirm, let me go back to the page, let me reload, and seems to be staying the same, which is great. Now let's look at the URL. It's more complex than Google's because we have multiple inputs. David, male, state equals MA. How do we get access to these other values? Well, first, let's do a quick and dirty thing, and let's just look at the entire contents of get. So let me go into register.php, and I'm going to cheat now. I'm going to output a pre-formatted tag. Recall that pre-formatted text uses a monospaced font just so everything looks like code. And what I'm going to do in here is instead going to do question mark equals $_ get. But this isn't quite right. Actually, let me put this on this line. So you'd like to think this will just print out the entirety of get. But let's see what I see instead. If I go to here, let me reload. OK, not that enlightening. It just says array. But that makes sense, because I did say get is an array. So we need to print it recursively to see what's inside the array. And the trick you can use, and this is not generally for production code, you don't say print, you say print_r for recursive. And it's a wonderful way of just taking a quick peek inside of variables. So I'm going to go to registered, reload, and there we go. So this is what it looks like. This is completely arbitrary formatting. This has nothing to do with the underlying implementation. It's just a pretty way of printing the information. And now I see 3 keys, name, gender, state, followed by 3 values. So this is just a nice sanity check as to what's actually in there. So now I can do something like this. Let me go back into register.php. Let me go back to saying h1 hello equals $_get name, close bracket, exclamation point, close h1. Now let me do this again, and I'm going to say something like you are a, and this is going to be a little underwhelming at first. Let's just do gender, and then close that h1 tag. And then finally, you are from state. So this should hopefully follow logically from what we did a moment ago. So let's reload now, and font's a little big. Not the most user-friendly thing, but at least we're on our way. However, notice that there's no security mechanism in place here right now. There's no sanity checking of users' input. And notice we used get. Recall the URL looks like this. So what if I instead do something like this? This is not like a correct website right now. So there's opportunities here, right? There's opportunities to, 1, make sure that what the user, what we provided to the user as options are actually checked on the server side. 2, we can make it more user-friendly. It'd be nice if Massachusetts said Massachusetts, not MA. It'd be nice if the M became male in lowercase, or you are a guy, or you are a girl, or just something. So there seems to be opportunities here for if conditions, and else's, and some kind of conditional checks, and so forth. So we can build up there. But one of the most important takeaways is that right now we're just trusting what the user has submitted to the form. And this in and of itself is not a good assumption, because we can do something even worse than this. This is a very common thing known as a cross-site scripting attack that I'll talk about more toward the end of the semester. But if you're familiar with JavaScript, even minimally, what if I do something crazy like this? You have been hacked, question mark here, close script tag. OK, that's my name, I claim. All right, so what's going to happen now? Well, because of the server-side code, what am I doing with the name parameter? Yeah? I'm closing the script. Well, and I will actually notice here, I closed it, but I also opened it. What am I doing in register.php with that value? Yeah?
You're actually going to send that string to the user, and the user's browser is going to interpret it as a JavaScript.
Exactly. I'm literally going to spit out what the user typed. But if the user typed HTML, that's going to add it to the page, and that HTML is going to be executed or interpreted. And if it's a script tag, it means the JavaScript code is going to run. So in short, what we just did, it's amazingly simple. Too simple. Very bad. Like, this is not good code. And many websites make this mistake, because watch what happens now. If I go here and click register. Uh-oh. What did I do wrong? Register, alert, script, type. Stand by 1 second. My dramatic alert. You have been hacked. Chrome, are you doing this to me? That should be OK where we put it. Semicolon. Let me go back. You have been hacked. That should be OK. Let me try one other thing. Otherwise, this is going to be a very underwhelming. This type equals. Oh, my God. All right. Stand by for 1 second. We're going to try one other thing here. Otherwise, you will never believe anything else I say. OK, 151128. Register.html. OK, so before I tell you what I just did, we're going to try this again. Script alert. You have been hacked. Massachusetts. Oh, damn you, Chrome. OK, Google is being too helpful for its own good. So Google is detecting what we just did and is scrubbing that apparently for us, which is rather good and bad of them. So this was the effect I was trying to create. So I very quickly opened up Firefox instead, which apparently doesn't have this protection in place. And this is not the behavior we wanted. But as soon as I click OK, we should at least see some of the behavior I expected, but not quite all of it. Now this is stupid, right? You're an idiot if you're trying to like trick yourself into executing JavaScript alerts. Like this is not really threatening anyone other than myself. However, if you think about how we did this, notice what's in the URL there. So apparently you can trigger these kinds of tricks by typing in input manually to forms, but that's the silly way of doing it. What if instead you're a bad guy and you're doing like a phishing attack, sending people bogus emails, and you're telling them to click a link, and they don't necessarily see the whole link because it's hidden with HTML email formatting, but they click that link, they get led to my page, and then some JavaScript code executes. Well, this too is stupid JavaScript. Triggering an alert is not hacking anyone. But as we'll see in a few weeks with JavaScript, you also have access to a user's cookies in JavaScript, which means there are attacks that we'll talk about later in the semester whereby you can steal someone's session cookie, hijacking their session in the same way we discussed on Monday with Firesheep and Starbucks and the like, by having tricked a user into typing or clicking a link that it takes advantage of this failure to escape the user's input. So the fix here is actually relatively simple, if tedious. In my code, you never, ever, ever, ever want to trust what the user has typed in. So the real way to echo user input is something like this, HTML special chars, which is an annoyingly long function name, but it is a very good function in that it will ensure that any potentially dangerous characters, among them the open bracket, which as you know demarks the start of an HTML tag, will be escaped, so that now if I go back and resubmit the exact same form, now I look like the idiot because I've typed in, it's displaying exactly what I typed in, which you would think is the expected behavior anyway. So one of the recurring themes that we'll discuss, not just at the end of the semester but throughout, is how to take advantage of things like escaping, both for user input here, for JavaScript inputs, and most importantly for database inputs, so that ultimately you are not vulnerable to attacks like this. So what did I do to work around this? In Firefox, notice my URL is very different. In Firefox, what URL did I use to visit the website? The same website. Yeah, so go ahead. What is it? Yeah, so this private IP, 192.168.151.128. Well, where did that come from? Well, the CS50 appliance, the virtual machine I've been running, it's just a computer on the internet, albeit a virtual one. And because I'm running it in a program called VMware, which is, again, a hypervisor that allows you to run one operating system on another, notice in the bottom right-hand corner of the appliance, there is mention of my IP address. And this can change all the time. VMware, in this case, is acting as the so-called DHCP server, giving the appliance a different IP potentially every time I turn it on. But this is just a configuration we put here to always remind the human what IP address he or she has. So what is the implication? This is nice because it means I can, as I promised on Monday, minimize the appliance altogether, not even have to worry about getting too comfortable with the actual Linux environment. And I can just treat this as a remote server. Now, it's remote in the sense that it's remote as though it's remote. It's actually physically present, but I can still address it via an IP address here. And if I'm on my own Mac or my PC, depending on your OS, I can now just visit that actual URL with the browser, and it's as though I'm visiting a remote server. And if I'm really particular and I just don't like looking at this address, what I can do is what I did on Monday, whereby I can open up a terminal window, and I can do edit etc hosts, type in my password, and then remember we did this trick here. So let me go here, and then I can do davidsecretwebsite.com. And now, because I've taught my Mac to make that DNS association for me, I can change this to this, and now notice davidsecretwebsite.com is born, albeit only on my own local computer. So when I mentioned earlier that you can do development on your own computer, it's a wonderful way of doing website development because you can still simulate all of the realities of HTTP and DNS, but locally without needing an internet connection, without needing a remote server, without having to pay anyone for those services. You can spend those months up front working at home, in a cafe, at work, all without needing any of the physical infrastructure that's typically associated with the internet. So we'll also introduce you in the first project to this approach. But we've only just scratched the surface. So one, all I've been doing is echoing out inputs. But clearly a website like Facebook and Google take input. It checks the inputs with if conditions and elses and loops and whatnot. It does like writing things to databases. And it would also be nice, too, to move away from what seems to be a very sloppy start, whereby we've been writing HTML, and then I kind of dropped into PHP mode very quickly, then went back to HTML. This is not going to scale very well. So if you're coming to the course with a background in ASP or JSP or even Django or Rails, there are ways of cleaning up our code so that we can practice some good principles like let's keep our presentation separate from our data. This is one of these mantras that makes good sense, especially for large projects where you keep your HTML separate from your CSS, separate from your JavaScript, separate from your data, separate now from your PHP code. So even though tonight we've started to dive in with this commingling approach, and on Monday we'll do some more of the same, we'll also look at some common paradigms, among them MVC, Model View Controller, where you can really start to separate these things into more complex, more sophisticated, rather more cleanly designed applications. But for now, why don't we go ahead and adjourn here officially. We'll take a 5-10 minute break. Peter will get set up. If you'd like to remain for section, by all means do. Otherwise, section will be filmed as usual and be placed online by sometime tomorrow. And I'll linger around for one-on-one questions. Otherwise, we'll see you on Monday.